Alright, so let's give question 4 a go now. So it wants us to copy and complete this table. So we have quadrant 1, 2, 3, 4. So obviously that's going to refer to your circle, unit circle. Just labeling the quadrants, quadrant 1, 2, 3, 4. And we just want to measure, first of all, start with degrees. So if I start with the first quadrant, these angles are going to go from 0 to 90 degrees. These are going to be 90 to 180 degrees. So I'll write that down. The third quadrant is going to be 180 to 270, if I just add another 90 degrees, and lastly 270 to 360 degrees. Done. Now we're just going to do that in radians. Degrees was easy because we're used to it. Radians is our new concept. So if you kind of look at your unit circle as you go, it should be 0, start over here, you go that way. I know that the whole circle is going to be 2 pi, so if I go a whole rotation, it's 2 pi angle, so half of that would be pi, so 180 degrees is pi, and then if I half that, 90 degrees would look like a pi over 2, and then, so between pi and 2 pi, it's going to be 3 pi over 2, because what I did is I added pi over 2 to that, so that I always get 3 pi over 2 over here. So those 4 numbers, I encourage you to remember: 0 pi over 2 pi, 3 pi over 2, and I guess 2 pi as well. It's kind of like the 90 degrees, 180 degrees, 270 degrees, 360 degrees. They're a little bit we use that quite often. So first quadrant, 0 to pi over 2. Second quadrant is going to be pi over 2 to pi. Next one is going to be pi to 3 pi over 2, and my final one is going to be 3 pi over 2 to 2 pi. Now, all I need to do is figure out which ones are positive, which ones are negative, regarding sine, cos, tan. And the easiest way to remember that is using our acronym. If you remember the acronym, it is South Australian Tennis Club, or All Silly Turtles Crawl. So just make sure you can label it, because then you're easily able to identify which ones are positive and which ones are negative. So in the first quadrant, it's all positive, so they're all going to be positive. Makes sense. If cos and sine is positive, tan, which is sine over cos, is going to be a positive number. Second quadrant, sine is the only thing positive, so I'm just going to go ahead and write positive. I'm just going to write plus and negative because I can't be bothered spelling it, and then that means the other ones are negatives. Tan, third quadrant, tan's the only thing that's positive, so I'm going to write positive. I'm going to write it all in red. Positive, and then the other two are negative. Last one, cos is the only thing that is positive, so cos gets a positive, everyone else gets a negative. That's pretty much it. In which quadrants are the following true? I don't think B was, let's do B anyway. Cos theta is positive, so I want to write when is that truth. So I look at my cos theta and just write the quadrants that are positive for. So quadrant 1, and I'm just going to write quad so it doesn't look like question. Quadrant 1 and 4. Okay, next one, cos theta is negative, so that's going to be quadrant 2 and 4. Sine and cos are both negative. That's only one quadrant, quadrant 3. I'm just looking at these values. Next one, cos theta is negative, so I want a specific one, and sine theta is positive. Let's have a look. I got cos theta is negative over here, and then out of those two, sine theta is only positive for this quadrant, so quadrant 2. Done. So it was just looking at those and figuring out those values. Alright, 5 is talking about explain why cos 400 and cos 40 are the same. Well, thinking about the unit circle and thinking about the periodicity, I did say that you start from over here. Cos 40 is going to be between 0 and 90 degrees, so let's say about there, that's 40 degrees. That coordinate, whatever that coordinate you end up getting, cos theta, cos 40, sine theta, sine 40, so that x-coordinate, which we're looking for, is always going to be the same if I do another lap. So if I go ahead and do another lap, I go 40 degrees, but then if I do another lap, that's a 360 on top, so that will be 400 degrees now, because 360 is one lap. So that P of cos 400 is sine 400. Those two coordinates are exactly at the same coordinates, so they end up being the same number. So basically the reason is due to periodicity of unit circle. So cos 40 plus 360 is cos 400. So that is why it is going to be the same answer. Alright, use your calculator to evaluate. I'm just going to do these two, just because I don't want to sit here and do all of it. So what I'm going to do is go sine 60, I get square root 3 over 2, and then sine 135, I get square root 2 over 2. What I might have to do is a couple more because I need to complete this apparently. So I guess I might as well do these ones, I think will help. So sine 120. Hopefully what you should see, I'll just go ahead and do them quickly because it's only calculator. Hopefully what you will see is some similar answers depending on what numbers you have. Okay, I'm seeing some pattern. Hopefully you are too. Okay, let's have a look. So as you can see, these have the same answer. Different colours. These have the same answer. These have the same answer. These have the same answer. Well, what can you tell? So apparently, let's have a look at the numbers. Sine 100 and sine 80, if you add the numbers together, it's 180. Sine 150 plus 30, 180 again. 120 plus 60, 180 again. 45 plus 135 is 180 again. So as long as the two angles add up to 180, they're going to give you the same answer. So basically, if you ever do sine 180 take theta, it's going to be exactly the same as putting sine theta in. So for example, if I go back to one of the yellow one, what I'm saying is sine of 180 take 100, because that's the theta, is going to be the same as sine 100. So 180 take 100 is 80, so sine 80 equals sine 100, which is exactly what we have seen over here in the yellow example. So we can write that as a relationship, and that is one of the relationship identity that I have given to you at the top. So if you have a look, once we do all of these exercises, you get all of these kind of definitions, and that first one relates to what we just kind of discovered. Okay, moving on. Justify using your diagram alongside. Okay, let's have a look. Let's say I have this degree, theta. Let's call that 80 degrees, using that same example. So if I do 180 degrees, take away 80 degrees, that is 100 degrees. Perfect. So as you can see, 80 degrees and 100 degrees add up to the same thing. And looking at the actual kind of location of the signs, these are my y coordinates, right? These y coordinates are going to be exactly the same because look at the height. They're at the same kind of height. So that's kind of telling us why this identity works. So you just got to write that in words. Due to height being same and having same y coordinates, etc. Okay, so it says find the obtuse angle with the same sign as. So an obtuse angle that has the same sign. So sine is the y coordinate. So I guess it'll be sine 180 take theta. Is that what they are looking for? I'm just going to quickly check the answer. What was it for? What question am I working with? 7.